Okay, I'm going to just do on the test review for exam number 4. I'm going to do problem number 2, and I'm going to solve it all the ways we've learned. So the first way I'm going to solve it is by Gauss elimination. So if we're doing Gauss elimination, we're going to just set it up in a matrix with a 4, then a 0, then a 1, then a 7. Remember that we have to put in coefficients for all variables, so there's no y there. Then there is a 0 for x here, a 1, then a negative 1, then an 8. There's a 2, then a 3, then a 0, then a 10. So what we're going to want to do is get 1s on the diagonals and 0s below. So to do that, to get 1s on the diagonals, I'm going to take the top, and I'm going to be dealing with fractions, it looks like, quite a bit for this one, which is doable, but a pain in the butt, but it is what it is. So I'm going to take the top one and multiply it by maybe 1/4. So I'm going to say take row 1, times it by 1/4, equaling new row 1. So then I'm going to rewrite it. Then I would have, so I'm going to times it by a 4th, times it by a 4th, times by a 4th, times by a 4th. So then I would have now a 1, a 0, a 1/4, and a 7/4. And nothing else changed. We still have 0, 1, negative 1, 8, 2, 3, 0, 10. We now always get zeros in these two positions. So we already have a 0 in this position. So then we need to get a 0 in this position. So then we're going to take row 3, we're going to take row 1, we're going to times it by negative 2, add it to row 3, equaling new row 3. So then I'm going to show my work. So times by negative 2, times by negative 2, times by negative 2, times by negative 2. And then add it to row 3. But before I do that, I like to personally write down what I'm not changing. So 1, 0, 1/4, 7/4 isn't changing. Then 0, 1, negative 1, 8. So then I have 0 now. So negative 2 plus 2 is 0. 0 times negative 2 is 0, plus 3 is still 3. We then have negative, careful here, we got this. We have negative 2 times 4. Sorry, negative 2 times 1/4 is negative 2/4, which is negative 1/2. So we're taking negative 1/2 and we're adding it to 0. So it's negative 1/2. Right here, it looks like I'm going to have negative 14/4, which is negative 7/2, correct? They both divide by 2, so negative 7/2. Added to 10. So negative 7/2 plus 10. So I'd get a common denominator. So I'm going to times by 2/2. So that's 20/2. So then if you do 20 minus 7, that is 13/2. 13/2. So not loving dealing with fractions, but that's okay. So now from here, we want to get a 1 in this position. We already have a 1 in this position, so we're good. Then we always get a 0 in this position after that. So we get 1s on the diagonal, 0 below. 1 on the diagonal, 0 below. So now we need a 0 in this position. So we're going to take row 2, times it by negative 3, added to row 3, equaling new row 3. So writing down my new matrix here, we have a 1, 0, 1/4, 7/4. That didn't change. We then have 0, 1, negative 1, and 8. If I take row 2 and times by negative 3 and then add it to row 3, that would still be 0. Times by negative 3 added to row 3, I now have my 0. So times to negative 3, that's 3. 3 plus negative 1/2. We just have to be really careful. We can't mess up on little algebra mistakes. This is over 1, so I'm going to get a common denominator. So I'm going to be timesing by 2, timesing by 2. So that's 6/2 plus negative 1/2, which looks like is 5/2. We then have an 8 times to negative 3, which 8 times to negative 3 is negative 24. So we have negative 24. we're then adding that to 13 halves. So once again, we would put over 1. We would need a common denominator, so we're going to times by 2, times by 2. So this is negative 48 halves plus 13 halves. If you do negative 48 plus 13 in your calculator if you need to, that's negative 35 halves. So negative 35 halves. Then from there, we would want a 1 in this position. So think about what you're going to do. How would we make this a 1? How would we make this a 1? We're going to take row 3 and we're going to times it by 2/5 because then it would be 1. So if we times this, and think about it, you times by the reciprocal to make it 1. Times by 2/5, times by 2/5, times by 2/5, times by 2/5. All right, so we're almost there. I'm erasing this real quick. So then from here, looks like I'm getting, we're not changing row 1, we're keeping that like this. So now 0 times 2/5 is still 0, 0 times 2/5 is still 0. 2/5 times 5 halves is 1, that's what we wanted. And then if we take negative 35 halves and times it to 2/5, our 2's divide out, and negative 35 divides by 5 and is negative 7. We've now done Gauss elimination, which is just when we get 1s on the diagonals and 0s below. So now we just use back substitution. So now we have the true statement z equals negative 7. There's one of our solutions. We then go to this one. Our true statement would be y minus z equals 8. So now we have y minus negative 7 equals 8. So y plus 7 equals 8. So then we minus 7. So y equals 1. We then go to the top equation. We then have x plus 0y's plus 1/4, plus 0y's. So I'm not going to write that, sorry. Plus 1/4 z's equals 7/4. So let's plug in what we have. We don't know what x is, plus we know that 1/4 times z, which is negative 7, equals 7/4. So we have x plus negative 7/4 equals 7/4. So then from there, we're going to add 7/4, add 7/4. So x equals, it looks like we already have a common denominator here, which is 14/4. They both divide by 2. This becomes a 7/2. So x equals 7/2. So there's my solutions. I should be getting 7/2, comma 1, comma negative 7. So that was just Gauss elimination. That's not Gauss-Jordan elimination. So with Gauss-Jordan elimination, we would have just continued, and we would have got, now at this point, we would have got a 0 in this position and in this position. And then after that, we would have then got a 0 in this position. So it goes in that order. We would go here, and then here. And then we would already have our solution. Ding, ding, ding. And that would be Gauss-Jordan. Jordan just goes even further than this. And then we would have these solutions. I'll do that in my next video.